So let's have a look at this worked example. It tells us that the first step in extracting magnesium from one of its ores, magnesite, which is magnesium carbonate, is to dissolve the ore in hydrochloric acid. Now, all of that sentence really isn't necessary information for you to solve the question. It's a bit of background blurb that if you get something like this in a test or exam, you just scan over it. You don't need to invest in the fact that it's an ore. But it's magnesium carbonate. How do I write magnesium carbonate? What's the MgCO3? What kind of bonding is present? Ionic bonding, and it is MgCO3 because magnesium forms a 2+ ion and the carbonate is a 2- ion. It's dissolved in the hydrochloric acid, and we produce magnesium chloride. What's going to be, how are we going to write magnesium chloride? MgCl2. Why is it Cl2?
Because chloride forms a negative, one negative bond.
Yeah, because Mg2+, Cl-, Cl-. We need two of them. And carbon dioxide and water. So we have to write down all of our substances balanced internally correctly, and then we go back and we balance the equation. And if we look here, if I put a 2 here, the magnesiums are balanced, chlorines are balanced, the carbons are balanced, the oxygens are balanced, and the hydrogens are balanced. So that's all right. And then we should come through and include the states. So this would be aqueous, this is gas, this is liquid. And so now we know our mole ratio, but we were given in the question that we wanted to know the mass of hydrochloric acid required to dissolve 5 grams of magnesium carbonate. So our first step with 90+% of chemical calculations is to find the number of moles. We need to know the number of moles of magnesium carbonate we've got, because that's how we're going to find the number of moles of hydrochloric acid we need. To find the number of moles, we're going to use this relationship here, which means that because we have the sample mass, we need to find the molar mass of magnesium carbonate. How are we going to find the molar mass of magnesium carbonate?
Add the individual.
So on our periodic table, we'll find the individual atomic masses and we add them together. So that is 24.31 plus 12.01 plus 3 times 16, which is 84.32 grams per mole. Now we know the mass of 1 mole. We can work out how many moles we have if we only have 5 grams. The moles of magnesium carbonate will be the 5 divided by 84.32, which gives me 0.0593 moles. So if that's the moles of magnesium carbonate I have, how many moles of hydrochloric acid am I going to need? To find that out, we look at the mole ratio. So the moles of magnesium carbonate, the moles of hydrochloric acid in our balanced equation is 1 to 2. That's just the coefficients from the balanced equation. Which means, because this is one I have and this is one I'm finding, the moles of hydrochloric acid will equal 2 times the moles of the magnesium carbonate. Is that reasonable so far? 0.1186 moles. And now that we know how many moles we need, it's a pretty straightforward step to work out the mass. By rearranging this formula here, the sample mass of the hydrochloric acid will equal the number of moles multiplied by the molar mass, but it has to be the molar mass of the hydrochloric acid, okay, because that's what we're finding. So again, we would look up on our formula sheets 1.008 plus 35.45 to give us the molar mass of the hydrochloric acid, 36.46 grams per mole. So our mass of hydrochloric acid will equal the number of moles multiplied by the molar mass gives us 4.3 grams. Okay, so we have to convert the grams to moles. Look at the relationship within the balanced equation. So we work through moles, and then we come back to a mass again. And this is a very, very common kind of question in calculations. Okay, so we'll go over that again next lesson.